We've already talked in this course about sequences and how we can figure out if sequences converge and diverge and some different types of sequences and how to take the limit of sequences and different things like that. But now we're going to turn the page and look at series. Now series are very closely related to sequences, but they're not the same thing. In fact, you can see here the definition: a series is the sum of a sequence. So a sequence is just a list of numbers with a pattern to it, is one way to look at it. So an example here you see is 1, 2, 4, 8, 16, and so on. A series is adding those numbers together. 1 plus 2 plus 4 plus 8, and so on. So a sequence is simply a list of numbers, whereas a series is the sum of those numbers. Now a series can sum, it can SUM, SOME, so in other words it can sum a few of them. Sorry, it's hard to put SUM and SOME together. It may sum just the first few. So for example, we could do the sum of the first 5 terms, or the sum of the first 10 terms, or the first 20 terms. But you can also do the sum of the whole sequence, which goes on to infinity. And that's what we'll be doing most of the time, is doing infinite series. Now you may be thinking, well, won't that always go to infinity? I mean, if we keep adding more and more numbers, won't that just always go to positive or negative infinity? Well, actually no. There are times that you can add up an infinite amount of numbers and get a finite sum, believe it or not. So here we see an example of this. Let's say a ball is dropped and it bounces back with a height of 3/4 of its original drop height and continues to bounce 3/4 of the height from which it fell. What is the total distance that it will fall? So you need to imagine here a bouncy ball, or some kind of ball that can bounce, and it's dropped from 6 feet. So that's what it does first. It drops from 6 feet. Now then it bounces back up 3/4 of that height and then falls. So it then falls 6 times 3/4, which is 4.5. So let me just write that below. And then it would bounce up again and fall 3/4 of that distance. So you would end up doing 3/4 times 3/4. And then you do 6 times 3/4 times 3/4 times 3/4. Okay, so another way to write this would be with exponents. 6 times 3/4 to the first, plus 6 times 3/4 squared, plus 6 times 3/4 cubed. And so on. You could keep adding that up, because each time it would bounce up, and notice I'm not counting the distance it goes up as far as my total distance. I'm just doing what it will fall. So it bounces it falls 6 feet the first time, 6 times 3/4 of that distance the second time, because that's all it bounces up, and then 3/4 times that, which is 6 times 3/4 squared, 6 times 3/4 cubed, and so on. If you do this in the calculator, and if you keep adding it up, you would then add 6 times 3/4 to the fourth, plus 6 times 3/4 to the fifth, plus 6 times 3/4 to the sixth, and so on, then you'll actually find that you end up approaching a single number. And that number, if you want to try it and test this, is 24. So theoretically, I know in the real world this wouldn't quite happen, but if you did have something bouncing like this, it could bounce on infinitely. It could just keep bouncing and keep bouncing and keep bouncing. It would just bounce less and less and a smaller and smaller distance each time. And that total distance that it falls would get closer and closer to 24 feet without ever getting there or without ever going above it. So this is an example of an infinite series. Now we need to look at some notation, just how it's written. We use sigma notation, which we've talked about before back when we were doing Riemann sums. But this notation, the sigma, just remember, means sum. The n down here, right here, is your index of summation. That just tells you what variable to plug in for. This is your starting point. This is your stopping point, or really, when it's infinity, it's telling you there's not a stopping point. And then an is just your, that's just underlining there, nothing special about that. An is your sequence. And similar to what we said with sequences, diverges means it adds up to positive or negative infinity, or converges sums to a finite answer. Just so you know, the best way actually for me to define that is that converges is when the sum is a finite answer, and any other scenario is diverge. Because you can get some weird things where it really doesn't it kind of oscillates, or Doesn't quite go to positive or negative infinity, but it doesn't give you a finite answer either. So converges gives you a finite answer. Diverges is anything else that happens. Okay, one very important point. Just because a sequence converges, that doesn't mean the series converges. So if you look at this first series, 1, 1, 1, 1, 1, 1, that sequence converges to 1. Those numbers are approaching the same thing. They're all going toward 1 because they are 1. But the series 1 plus 1 plus 1 plus 1 is just going to grow continually onto infinity. So while the sequence converges to 1, the series diverges. Okay, another example. 1/2, 1/4, 1/8, 1/16, and so on. That's going to converge to 0. Those numbers are just getting smaller and smaller and smaller. But let's look at what happens if we do 1/2 plus 1/4 plus 1/8 plus 1/16. And I'm going to actually pull up a calculator and we're going to look at that together. So if we just follow this pattern, 1/2 plus 1/4 plus 1/8 plus 1/16. Sorry, I actually meant to be showing each one. So let's do this. 1/2, enter, plus 1/4, enter, plus 1/8, enter, plus 1/16, enter, plus 1/32, plus 1/64. Oop, let's see what I did here. There we go. Plus 1/128. Plus 1/256. Plus 1/512. Okay, I think you get the point. This is getting closer and closer and closer to 1 without ever actually getting there. So this is an example of one where you can continually add more and more terms and it doesn't actually go to infinity. It just gives you an answer of 1. So another thing to note is that even if they both converge, they don't necessarily converge to the same thing. While this sequence converges to 0 because the numbers are getting smaller and smaller, the series, the sum of those numbers, is converging to 1. Sorry, I don't know why I wrote 0 there. Converges to 1. So not only does one converging not necessarily mean the other will converge, they don't necessarily, even if they both converge to the same thing. Alright, that should be all you need to know before we get into some specific types of series. And we're also going to look a lot at just how to determine if a series converges or diverges.